Hello world, welcome back to another tutorial. Today we're going to be talking about how to put a camera in your scene, and not just any camera, not just a camera, because that doesn't mean anything. A camera could be a shaky camera to make it look like there's an earthquake, or a camera that follows your player, or a camera that just flies around the world like in Minecraft when you're in fly mode or whatever it's called. So yeah, it's pretty easy. It's not too complicated as long as you kind of follow along with the maths. Pretty excited to do this one because this leads into another episode of projection matrices, and then we should be in 3D in no time. So get excited. If you like this and all my other stuff, go ahead and like it or subscribe or leave a comment. Let me know what you think. Also, if you have any suggestions on how to make this game engine better, because that's the idea, is to make a badass game engine, let me know. You can do that probably you can do that in the comments or in the Discord channel. I left that in the link. And then you can also find all of this code online on GitHub. And I put that link in the description too. So yeah, let's go. Okay, so let's do just a brief overview of what the hell a camera means in a game engine. So say we have these two objects on the screen. We have a triangle on the left, triangle on the right, and we want to use a camera to move them about the scene. Well, camera actually comes in second. What comes in first is we need to move these models around in model coordinates in world space. So first thing we'll do is we'll take a model matrix and we will multiply that model matrix by every one of the coordinates on that individual model. And then we can move that model wherever the hell we want. Next comes in a camera. And so, you know, you probably think of a camera as an object that moves in space, a camera that moves in space. Like if a guy were videotaping a scene, he would just walk around and then that's the camera walking around. Well, in video games, it's a little different. In games, you're not moving a camera around the scene. The camera's in the same spot. You're moving the entire world in the opposite direction that the camera is moving. So it's the same concept, except as opposed to the cameraman moving around, the whole world is moving around as if you were on a treadmill and everything's just flying by you because it looks like that way. So that's what's going on. So to accomplish that, we will need a view matrix. We take this view matrix, we multiply it by every vertex in the entire world, and then the world can shift in the opposite direction the camera moves. Now, if you notice that the camera in this image is still in the center of the box, and that's because it never moved. The whole world moved. Pretty cool stuff. So let's just take another little example and kind of understand how these matrices work together. So we have a position in space, and so we'll say that this guy is in position whatever. It doesn't matter. These are just obscure numbers. Actually, I'm using identity matrices, which wouldn't even move this in the first place. But just kind of bear with me. We have a position in space, and we multiply that by the model matrix, and this will be per model, and he moves, just like I showed you in the last slide. But then we want to move the entire world. So we've outputted a position from the position times the model matrix. Now we'll take that position and multiply it by the view matrix. But really, we could just chain these together and say position times model matrix times view matrix, and that will move everything in the opposite direction, which gives us our new position in space, but the world has moved around. And so it's a pretty simple concept to apply a camera, and I'm excited to do this, so let's get into it. Okay, and on to the code. So let's go ahead and start with creating a camera. So in game objects, what I'm gonna do is I'm gonna go ahead and actually game shiz. I'm gonna create a new group, and that group is gonna be called cameras, because we're gonna make different kinds of cameras, and I'm gonna place that under game objects. Node will go about there. Okay, so node, scenes, game objects, cameras. So in cameras, we're gonna create a new file, and I'm gonna just call it camera. Now, camera isn't an object. Camera is going to be a protocol. So let's make a protocol called camera, and let's give it a position, because cameras have a position in space, and yeah, and that will be a float 3, and we're gonna say this can be get or set. We're also going to need to have camera types. So camera types, we'll go enum camera types. And then the first case, we want to make a debug camera. The debug camera could basically fly around. It's just a point, just our starting camera type. Well, we can add more in the future, but every camera, there can only be one camera type at a time on the scene, which is a good thing. So case, we'll just call it debug. And yes, so the camera will need to have its own camera type assigned to itself, because a camera can't be both this camera and this camera at the same time. And this might be a bad design, I'm not sure, but I think it should be good. All right, so camera type will only be a get. We will need to import, let's see, SIMD. We don't need metal kit or anything like that, I don't think, for now. And then there's one thing that the camera has that nothing else has, and that is going to be a view matrix. But instead of making us initialize, because so the view matrix is basically just everything's opposite position, right? Like I said before. So just like our model in our node or in our game object, well, let's go to our node. Just like our model matrix has, translate, rotate, scale. Well, our camera can have a translate and a rotate. So basically, instead of translating in the direction that we want all the objects to go, we're going to translate in the opposite direction. So let's go ahead and go var view matrix. This will be a matrix float 4x4. We're going to instantiate that. We can say var view matrix as, equals the identity matrix identity float 4x4, and we'll just return this view matrix. And just like I said, the only thing we need to do for now, since we're not rotating, we just want to translate the direction in the negative position. Build failed because I spelled something position wrong. Cool, that should build. Okay, now that we have a camera set up, we actually need, okay, let me add one more thing, func update. So as we update the camera's position, we will need to call update to set that position. And that's gonna be clear once we get to it. So here's our basic camera set up. Let's create a debug camera, because we have a case of a debug camera. Let's create a new file, and I'm gonna call that debug camera. This will just say class debug camera as a camera. And then it's gonna yell at me to put all of the protocol stubs on there, just like so. The position of this camera, like you can set it to whatever you want at the very beginning, but we're just gonna set this one to be at the position of 0. We need to import SIMD again. And the camera type will be camera types.debug. And then when we update, we're going to want to do things. So let's do some stuff. So the update function will update the position, most likely, of the camera, or maybe make it shake if we want it to make it look like an earthquake, whatever it does. But for now, all we want to do is say if keyboard.is key pressed, let's do left arrow. We're gonna use the arrows. Then we will want self.position.x minus equals, let's just do delta time for now. Yeah, because we could have a speed or something of the camera, but for now, let's just do it that way. And then I'm gonna add one for every direction. So position.x plus equals, when we press the right arrow, then when we press the up arrow, we will want the Y direction to increase, just like in any object, right? As we go up, the Y increases, and then we will want the Y to decrease when we press the, down arrow. Cool. All right, so we've created our cameras. Now let's freaking use them. Like I said in the description, we will need to multiply our model matrix by the view matrix. So let's go create a type So just like how in our shader, let's just kind of review. In our shader, we have model constants, and that's this struct that's passed into buffer 1. Well, just like that, our scene is going to have multiple scene constants, like our projection matrix, our view matrix. We're going to have maybe the fog density, it doesn't matter. But we will need scene constants to go along. We don't want to just pass in a camera here. We want to pass in scene constants. So out in our core.types, let's go ahead and create a new struct called scene constants and implement that in the exact same way we did our model constants. I'm going to create a view matrix, which will equal a matrix identity, float 4x4. And then we're going to pass this scene constants into our buffer. Let's go to our scene, add var scene constants, which will be, let's just set that equal to scene constants. And then while we're at it, let's just create var camera for now, which equals a debug camera. Boom. And we're going to need to override the function for update. So let's go override update, and then we'll call super.update so it updates everything else. But in the meantime, we're going to call super.update, and then this will say camera.update. Cool. And then we'll need to override the render function, super.render. And inside here, what we can do is we can go render command encoder dot set vertex bytes. We're going to pass the reference to scene constants. Scene constants dot stride is the length, and then the index will be, well, I like to set my scene constants at 1 and my model constants at 2. So let's put scene constants to 1, then go back to our shaders and pass in our scene constants here. At buffer 1, and then update this model constant right here to be number 2. I just like to do it in that order. That's just how I do it. We don't actually have a scene constant type that corresponds to the types. So let's create another struct in here called scene constants. Float 4x4. This will be the view matrix of our scene constant. And if I build, everything should be happy as soon as I put a semicolon. Cool. Yep, so that's gonna compile just like in the description now. So we have our model matrix times our position, but let's just chain them together. And at the very beginning, this is important that you put this at the beginning. We can go scene constants.view matrix times the model constants.view matrix, or model constants.model matrix times position. So it goes in inverse order. This is just how matrix multiplication works. But here's our original position. We move the object and then we multiply it by the view matrix, which is like the overarching view matrix of the scene at the current time. Or when I say view matrix, it could mean it's the parent matrix. So yeah, remember it goes view M P, but really I just memorized this one. This is MV, and then after this one in front of here, we will put a projection matrix. So it's really easy to remember MVP, just kind of a mnemonic to memorize that. So MVP. Cool. Beautiful. Build succeeded. Let's go back to our scene here. Actually, yeah. Let's go to our scene. We're setting the scene constants at 1. Let's go to our game object. Now, remember I moved it to 2 in our shader. This is now at 2. So our game object needs to be bound at index 2. And that makes a little bit more sense. Then in our scene, we have index 1. We're going to render. We're going to update our camera. Let's go ahead and press play and see what happens. So nothing is actually happening. Why is nothing happening? nothing is happening because I'm not updating the camera's view matrix to be the position, or the scene constant. Excuse me, I'm not updating the scene constant to have the camera's view matrix. It's just a matrix identity float 4x4. So I'm going to create another function above update, and that will be func update scene constants. And that will simply say scene constants dot view matrix equals camera dot view matrix, just like so. That's a little bit nicer. This makes a lot more sense. And now if we click left and right, nothing actually happens because I'm not updating the scene constants. So let's go and update. We'll go update scene constants can go under camera.update. Update scene constants. So we're going to update the camera and then we'll update the scene constants for everything in the entire scene. And now, if I'm not mistaken, wow. Look at our camera. As you move left, everything moves to the right. As we move right, everything moves to the left. And up and down and the same thing. So it's like there's a guy behind our camera, but really it's just every model is moving on that matrix. It's really cool what matrices can do when you multiply them together. So that's how we're gonna do that. Now we have our camera moving, but we can only have one camera at a time. We can only have a debug camera on the scene. That doesn't make any sense because what if we wanted to maybe make it, add a camera from another point of view of a player, or, change just the camera in general. We want to point backwards, but we don't want to update the position of our current camera to be pointing in a direction. Like we want to add multiple cameras to the scene. How could we do that? Hell, we might even just want a freaking, like when we do reflections, we have a camera, an eye perspective, and then we want to reflect it off a scene and get the reflection at that certain camera angle. It doesn't matter. We want to be able to add multiple cameras to our scene very easily. So instead of just creating a camera here, let's create a manager called camera manager. Camera manager. And so this will just be class camera manager right there. And this, unlike the scene manager, which is a singleton, camera manager will not be a singleton. Every scene will have a camera manager, var camera manager. Like so, okay? And the camera manager is only gonna have a few functions, and I've already kind of created those. So let me just copy everything that the camera manager will have and paste it on here, and we'll just go over it. Okay, so we already have camera types, don't need to worry about that. But yes. Okay, so we have a dictionary of cameras. We have a current camera that is set, and so this pattern we're using in the camera manager it's actually a design pattern, and it's called a strategy pattern, which allows us, like the strategy pattern basically means we can update the algorithm we use at runtime rather than before the at compile time. And so as we register cameras, we can set cameras. So we're gonna register a camera right here, and then we can set the current camera that is being used, and then we're updating every single camera all the time so that we can easily switch between each camera. So this right here is the way we're gonna set up our camera manager. This is called the strategy pattern, and this is a really good thing for interviews. If you are ever asked about updating algorithms at runtime, say strategy pattern, you'll look cool. So yeah, now that we have all of this camera, we'll have our cameras, we have our current camera that we're using, so we'll get the view matrix off this guy. We'll register our cameras, we'll set our cameras, and we'll update our cameras. So the update, let's jump back into our scene. So in our scene, we say camera.update. Well, we're already kind of doing that outside of here. We're doing that back in the camera manager. So we could call camera manager.update. So I'm gonna do that right here, func update cameras, and that'll take in a delta time, float. And yes. We're not going to do that there. Move that from update. We will say camera manager dot update delta time lowercase camera manager. Cool. So now we can call update cameras from outside of here. And what do I mean by that? Well, we have a scene manager, and every scene will have a camera manager. So in our tick scene function of our scene manager, go ahead and just call current scene dot update cameras with delta time. So you'll see we have a sequence of events. We have our update of cameras. We have our basic update, which will update all the game objects and GUIs in the scene. Maybe not the GUIs. This will probably just be update models. And then we're going to render our scene. So now we've extracted the update cameras from outside of our scene class. And yeah, it's pretty sweet. Let's get rid of this line. I'm going to get rid of this line too, just make it a little more clean. Now, I know what you're thinking. Now that we have a camera manager, we don't need this camera right here, right? Right, so let's get rid of it. Actually, let's not get rid of it yet. Let's create one more function. I know I'm creating a lot of functions, but this function will be add camera. And this will basically just take in a camera. So our scene will have add camera, and we say camera manager dot register camera. And then we'll say camera, just like so. So as we add cameras to the scene, we will be able to use them. But one thing I want to be able to do is add a camera and set it on the fly. So I don't need to call register camera and then set camera afterwards. So let's pass in another Boolean. So is, let's say is current camera. And we're going to default that to true. So anytime we add a new camera, we're going to default it to true. And so I'll say if is current camera, then we'll go camera manager dot set camera as camera dot camera type. Sweet. So we're going to add our camera, we're going to register it, and then we're going to set it. And then we'll be able to set our camera very easily in the future to any other camera that's on the scene. So back in our sandbox scene, we have our player. Before I go any further, I'm going to rename player to a pointer because that's what it is. It's not a player really. We have a bunch. There's usually only one player that we're controlling at a time. I mean, there could be two, but player doesn't make any sense. So pointer makes a lot more sense. If I build this, this will throw the errors. This is a really quick way to find all of the errors, but my assumption is they're just in sandbox scene. And I just need to rename all of these to pointers. Like so. So if I press play now, you see we still have the same stuff going on. Oh, so apparently in my scene I have a problem here. Add camera, didn't add a camera. See? So I went to add a camera and nothing happened, or I didn't add a camera, so nothing happens. So what I need to do is back in my sandbox scene, let's add a camera, right? Boom, it's that easy. So I can say add camera. Let's go debug camera. Press play, and everyone's happy. So look at how easy it is to add a camera and set a camera. Oh, my goodness. So I'm gonna actually instantiate this right here. Var debug camera equals debug camera. We'll add this debug camera. And then we need to go back to our scene where we call update cameras, update scene constants, gets the camera.viewMatrix, because that doesn't make any sense. So let's get rid of this camera. We're not adding that camera. We want to add the other camera, but you'll notice all of these this camera is going to break, because it doesn't make any sense to call camera. There is no camera. So let's say camera manager dot current camera dot view matrix. Then we will press play, and hopefully everything works out perfectly. Yep. So this is working, but you'll notice that we're not following everything's kind of off. And I'm going to fix that. We're going to get rid of this, like I said, in the next episode probably. But for now, let's figure out how to make this work. So it looks like our mouse can't really know about the objects in the game engine, but we can definitely pass down to the pointer the camera. And then, because all we need to do, let's press play one more time. All we really need to do is update the mouse position, or the calculated position, to include the camera's position on the screen, because right now it's at 1, and this doesn't know that it's at 1 or wherever it is. So let's update this to say camera position. So I'll need to take in a camera to the pointer, and we will instantiate it var. We'll go private var camera as a camera, and after we call init, we will say self.camera equals camera, and then down here, and where we're doing the rotation calculation, let's just add camera.position.x, and then also right here plus camera.position.y. That should give us a break. We now have a missing, back in our sandbox scene for our pointer, we are missing an argument, and that's because we need camera. And we'll just take in that debug camera or current camera, whatever we want to be using at the time. That just kind of is based on the game logic. But now you'll notice as we place it in the scene and move it left and right, it will follow our flippin' pointer. Pretty cool stuff. So hope you guys enjoyed that. That's kind of fun now that we have a camera moving about the scene. Hopefully in the next episode, I haven't gotten it together yet, but we will be doing 3 dimensions. We will be showing you a cube, hopefully, and I'll show you some cool stuff with that. So yeah, hope you guys enjoyed it. Like, subscribe, Discord channel, all that shit. Leave a comment. Love to hear from you. And yeah, see you next time.